Hello and welcome everyone to the 8th episode of Podchat. Today we'll be having a first year MEC student from Paris, Sankarshan Sahu. So let's head to the conversation and let's get to know about his journey. Welcome Sankarshan to the Podchat. So how's going? How's your life going? How's your work going?
It's all good. I can't complain, but yeah, we have a lot of pressure. It's quite a rigorous coursework, which I'm in currently. But yeah, it's good.
Great. So can you briefly introduce yourself to the audience for us?
Okay, so I'm Sankarshan Sahu. I did my bachelor's in civil engineering from Indian Institute of Engineering, Science and Technology, Shibpur, and currently I am a master's student at Sorbonne University, and I'm doing my master's year 1 M1 in a program called the Paris Physics Master's Program, and that's about it. Yeah.
So how was the shift from civil engineering to physics? I am sure many of people have already asked you this before, but still.
Yeah. So the jump has been pretty interesting, and I think it's like, for me especially, it was a very good learning process, a learning curve. So first of all, what happened was, in my bachelor's, we had a professor take our physics class, and at first I was really interested by physics. Even during my childhood days, I was very much interested, and that's why I took up engineering in the first place, because I thought that we'd have some application-based physics, it would be fun, but I just think that it was not it. Maybe because I was more interested in the mathematical part of physics. That's why I think engineering was not really a suitable option for me. So I decided to go on this. So I thought at first that maybe, okay, I can live with engineering, because after all, it's applied physics in some sort of sense. But again, yeah, I had a course taken by a professor called Krishnendra Mukherjee, who has helped me a lot, actually, in my transition from engineering to physics. And then I was really, really interested in it, especially in quantum mechanics, because it was something that was totally non-intuitional and it was totally new. So I had to explore it, and then I was on my journey. I just slogged in long library hours, read about quantum mechanics from different books that I could gather. And yeah, that's how my interest grew. So like all of the normal physics students, they have their undergrad, the Griffiths book in quantum mechanics. That's where I started. And then, it just went on growing up. So then I became interested not just in quantum mechanics, but also in subjects like electrodynamics, stuff like that. And then what happened was, I had some sort of an idea. Then, yeah, one thing is very important, that you should not be afraid of anything. So yeah, I had an idea. I presented my idea. I had received some reviews on that. And then the process built on. Then I was able to get some internships, do research, learn more about the subject. But it's vast. One can't ever say I have learned it completely, because there is no completion. You complete the subject. Right? But yeah, that was the turning point. From my first year, after I had taken the course on physics by the professor, and then I went on. It sort of built on from there, like an avalanche.
Right. So did it ever occur to you that maybe you can drop out of engineering and pursue a BSc as well?
Did it ever occur to me that I can? See, there are times in your lives when you are at your lowest low, and you will have all sort of bad thoughts. And maybe it was one of those thoughts that, yeah, I think I should just drop out of BTech and study a BSc degree and pursue it the normal way. But then again, the thing is, for me personally, in my case, it wasn't an option. It wasn't an option for several reasons. One of the reasons may be the financial one, that, whatever happens, at the end of the day, engineering will give you a job if you do it decently.
Right.
It always will, right? But you can't say the same for BSc.
Right.
Practically speaking. This was one of the points. And the other point is, engineering is maybe not the best career option, or depends upon you. It may be the best career option curtailed to you. But one thing it is, that is, it provides you with a lot of time to really think about what you want to do. Engineering is a very, very flexible option in India. People do MBA after engineering.
Right.
That's entirely different. People do it. People do MBA after engineering. People can go to research in their core engineering fields. They can go to IT sectors, even being from a different background.
Right.
So one thing engineering does is provide you a lot of flexible options and a lot of time in hand, and it's upon you to use that time. So I thought, why not give it a chance? I have a lot of time in my hand. Just pursue engineering, and I'll do physics sideways. And yes, I had some thoughts that maybe I should just drop it and do it the normal way. Then maybe the journey wouldn't be as much fun as it has been for now.
Great.
It was good. All good.
Great. So, did you do some extra courses for credits as well, or you were just simply self-studying on your own along with taking help from your professors?
Yeah. So my university was a pretty rigid one. The coursework was rigid. It was not at all flexible. I tried, but I didn't do any extra. I couldn't get any extra credits. But it was all self-taught, self-learned. And one of our professors I actually tried to audit one of the professors' course, and I used to go to him.
Okay.
Go to him for the classes, and he used to let me sit in his class. But at the end of the day, I didn't get any official document stating that I have attended this course.
All right.
And I have a grade for it, something to show up. So it's all self-learned.
So did it kind of hampered in your admission to masters abroad, or it was not a much of a problem?
Definitely it did, because come on, you are from an engineering background, so they will obviously prefer students who have coursework listed in their profiles that they have done this course and they have got this much grade in that course. So it definitely will. Your chances are not as much. So let me do it a little physicsy way. So your chance, so the phase space of that is available to you while applying to the master's program for an engineering student is much lesser compared to the phase space that a physics student has. And you are granted this fact. You will definitely face challenges, but at the end of the day, if you have worked your way around it, you should get one.
Great.
Maybe you should not get one. Maybe in the first chance you won't succeed. It happens. But repeated efforts, you will definitely end up somewhere. I can just say that.
Okay. So what I have also seen with my fellow batchmates or my seniors in my college is, especially in civil engineering, there is a bigger problem, because other fields are also relatable to physics, or there is CS application or there is mechanical application. But as a civil engineer, it would be some extra difficulty to jumping into physics. So what were those?
Yeah, the civil engineering, the difficulty is extra, but what I think was, there are certain things that I would like to point out. One is every engineering background, whatever it may be, they have math courses, right? We have engineering mathematics. We have engineering mathematics 1, 2, and 3. It's very important to do those courses nicely, because those courses provide you a very good, strong mathematical background that is needed for physics, especially in theoretical physics, right? And for subjects so I was mainly interested in quantum mechanics. For quantum mechanics, be it from whatever the hell field you are, it's completely different. So it does not, be it from your mechanical, be it from maybe you're from, metallurgy, mining, civil, be it from computer science background, electronics background, it's all the same. Quantum mechanics is such a different thing in many aspects. That the challenges are almost the same. But there are some subjects for example, thermal physics and consequently statistical mechanics that maybe some people switching from mechanical will have an advantage on, or there may be some subjects in electronics which will definitely be favored by electronics, which the electronic students will definitely be having a good time getting accompanied with, right? That sort of advantage I did not have, but it is not a very big problem, because you can always develop skills. Maybe it will require a little bit more time, but definitely develop the skills anyway.
Cool, great. And so, how's life in Paris? What was the cultural shifts, or maybe you must be facing some food problems initially, or some other logistic issues. So, can you tell us about that?
Imagine a guy who has never cooked his entire life, cooking 7 hours, cooking 7 days a week, so that he can save some money. So that is me right now. See, the thing is, though my program is almost fully funded, but living in Paris it's not a cultural shock, it's a financial shock. It's very expensive. Paris is one of the most expensive cities in the world, right? So yeah, so you need to cope with it. You learn as a human being. You learn different aspects of life, not just physics. So you learn how to save money. You learn how to how to manage your time efficiently so that you can do certain tasks in certain order that optimizes your way of living. And the cultural shock, I think one which I received was the interaction with the professors over here. The professors and the students, when they interact, they are on equal footing. They see you as your equals, and then they interact, and then you ask questions, and then they reply to the questions. You are all on equal footings. While socially speaking, they're definitely above us in the ladder.
Right.
But while they interact with us, will they react to our questions, they don't see us as someone who is below us, and we can just feed them whatever they want. No, we are just equal.
Right.
And they treat you in that way. And that I think is very, very good, and something that should be immediately also adapted to the Indian culture. So this was a cultural shock, maybe. And the cultural shock. These are the cultural shocks that I saw. And there are different, like, one of the difficulties I have faced over here is like people don't speak a lot of English here. You need to be proficient in French, which I am not at all at the moment. But you can get by because people in universities do speak French. Your professors do speak English. Your professors do speak English because that's how you communicate, right?
Good.
So it may be difficult at first, but you will settle in.
Good.
For sure.
Great. And so, do you have any siblings who are into science or?
Not really. No, I am the only child. And I have cousins, but not siblings.
Okay. And so, how were your parents supportive enough for you to pursue such a long line of academia?
Yeah, they were very supportive. In fact, like, one of my mentors has been my grandfather, and even my parents' entire family has been super, super supportive. And I couldn't ask for more, They were just like, whatever you do, at the end of the day, you must have something to feed yourself and you should not be dependent on us. Other than that, do whatever you want because it's your life and you need to be happy at the end of the day, whatever decisions you take. So in that regard, they're really very supportive. And even now, they are supportive of my decision or whatever I plan to do next. That's very helpful.
Great.
It's not something that all of us are blessed with, but I am, and I'm very lucky in that regard.
Great. So how were you as a child? Were you like poking to your teachers, asking too many questions, or asking, like, troubling your parents with the questions like how the universe works or something? So how were you as a child in school?
Okay, that's an interesting question. I never thought of it. So how was I as a child? As a child, I was quite the nuisance maker. But I always poked people with a lot of questions, a lot of it. And my teachers were sometimes... it happened once that I, with my mother, went to a tuition teacher. And my mother said that he has a very big problem, that he will ask you a lot of questions. And then the teacher said that yes, he should do that. He should ask a lot of questions, but the question should be sensible one. It should be in relation to what I teach, not over exaggerated stuff, right? So yeah, so there are many people who even likes people when they ask questions, and yeah, you can say even here, this was one of the cultural. This is not one of the cultural shocks, I'll say, but yeah, I have seen more people encouraging questions. Every one of the professors I have interacted with in here encourages you to ask a lot of questions. So yeah, I have been like that as a child. I was quite the nuisance maker, but at the same time, I asked a lot of questions.
So what your experience been in how the academic structure is different in Paris as compared to India?
Well, yeah, one thing I would like to say, and that people are very, very misguided, I think, in this regard. People say that grades don't matter and stuff like your experience matters, your research matters, which is actually true. At the end of the day, your experience matters. You should know the stuff. But to get into good opportunities, especially in academia, especially in the field I am, or I want to do, that's theoretical physics or quantum physics, your grades are very, very important. I used to think India was grade centric, but I came in France and I think it's now even much more grade centric. than in India. But there's a huge difference. The difference is the exams they have, like we had the quantum physics exam or the statistical physics exam, they are really, really tough. And some of them, the paper, you can't finish it. You can't finish, and that's their motive. Like in the quantum mechanics exam, we had a four-page paper, back and forth, back and forth, and it's just I should do that in 3 hours. And the professor said, I to see how much farther you can go, right? And there's a certain thing that they will never repeat the previous year questions, and the questions they have maybe are based on their own research. Maybe they're doing an experiment in the lab in the morning, and they will give the questions from that experiment in the evening in the paper. I have to think about it. So the exams are very, very different. The exams are very, very fun to deal with, which I think lacked in the system that I came from. The questions were very repetitive, and at a certain point of time, I think even memorizing would help you get through some part of the paper. But here, this is definitely not the case. Here, you need to really know the subject, know it to the core, to be able to answer the questions and pass. Also, here, like in France, it's not the case with I don't think it's the case with other European countries. Having a pass mark is considered good. Because many people fail. Like the pass mark over here is 50. 50 out of 100 is the pass. And you know, the kinds of questions they set, if you are not thorough with the material that they have taught and you don't understand it, you just, maybe you have memorized it, that is not going to work. You need to understand the material very, very thoroughly.
Got it.
This is the main difference that I compare to the Indian system.
So if you remember, like in childhood, what was your that moment that brought you to physics? Like, why are you into physics?
Maybe it was not a moment; it was a collection of moments. But yeah, so from my childhood, I had a dream that I would, I would make robots and stuff, and I'll change the world. I would have some contribution to technology as a whole. Yeah, right.
Great.
Yeah. But then, as I grew up, one book I read and I would suggest others reading is The Brief History of Time by Stephen Hawking. And that was when I got really into physics. And there, he explained the space-time cone that you will read later in relativity. He explained in such subtle and simple language that it's a worthy read. And yeah, and then I used to gift my friends books from Stephen Hawking and Einstein. And after 2 to 3 weeks, I realized that it wasn't worth giving them the books because they wouldn't read it. Right? Because not everyone is as interested as well, which is fine. Definitely fine. But what I used to do was then I used to take the books back. Like so I give this book. Can you give it back to me? I'll just read it and I'll return it. Then I should return it, but then so I brought books for them. I used to give them as a present. Then I used to see that they are not at all interested. I used to take them back and maybe read the books, and that helps a lot. And yeah, this was what kept going on for quite some time, and that is how mainly I got interested. I read quite a few books. So there's also a book by Einstein called Relativity, the Special and the General Theory.
Right.
I remember I bought that book at class 8. I understood nothing of it. Absolutely nothing. And then I used to spend chunks of time from class 8 building up something so that maybe one day I'll understand the book. And by the time I was in class 10 and we had and the board exams got over, I sat down with the book, and believe it or not, I was able to understand special theory of relativity just by self-learning.
Great. Nice.
Because I spent a considerable amount of time, but I was able to do that, and that for me was a particular instant which I look back to and think, I think that is the moment when I thought that I think I should go into physics, because that was incredible, like an incredible experience for me to understand something that Einstein preached, and an incredible moment also in the regard that I did something big. I understood that, so maybe this is the path I should later follow on in life, and which I'm doing right now. So that turned out great.
Great. And so, who has your role model been throughout your journey?
So it's been a personal one. My first and foremost role model has been my grandfather. He has been a very, very big motivation for me. I've never seen a person work so hard in his life. And I think I want to work that much hard and with that much concentration, because the amount of concentration he has is incredible. So personally, my first and foremost role model has always been him. And then I have I take inspirations from people. Like, it's not a sole role model, a person with perfect qualities that I would like. But yeah, for example, I like the wit of Feynman, his humor. I also like the fact that Paul Dirac would be able to concentrate on something for hours and hours and wouldn't socialize, wouldn't do anything, and have that concentration power. So these are some personality traits I like from other people. But yeah, my first and foremost role model has been my grandfather, as I've said before. And then I have some, I like personal gimmicks of some people, like personal traits of certain people I would like to incorporate in my life.
Great. That's great. And so what is your long-term vision? What do you plan, even like not just career-wise, but even where you see yourself in 50, 60 years after that? What do you want to achieve in life?
And I don't think I will live that long the way I eat. But yeah, yeah. So my long-term vision is I would like to do full-fledged research in the area of theoretical physics. I yet don't know what it is, because there are a lot of things that interest me.
Right.
Quantum computing, quantum information, maybe string theory at some point of time, quantum field theory. A lot of things that interest me, and I would love to explore all the areas and love to have contributed to all of those areas at some point of time. And I would definitely also like to guide other students to their own research future, to their own parts of research. Maybe as a professor, I would love to guide PhD students and see them succeed in my life as well. But I haven't thought so much in the future. But I have a rough idea of what I want to do, and I think my rest of the life would be dedicated to following that path.
Great. And so did you face any times of uncertainty or fear during your journey, like whether you had self-doubt or dilemmas that whether should I do this or do that, or yeah?
All the time. Even right now I face it. But the important thing is, do not be deterred by it. And one thing I would like to say, I think I also read it somewhere, maybe I read it yesterday, that whenever you have uncertainty in your life, just get occupied with so much work that you are, at the end of the day, you are just too exhausted to think about anything, and you just sleep. So you don't have any uncertainty because you won't have any bad thoughts that would arise if you are free. So you're not free. You work all the time, you get exhausted, and you come back.
But isn't that would have a negative impact as well, like being a workaholic attitude, and it would kind of have in the long run have more negative impacts as well, don't you think?
Yeah, I don't think being workaholic is bad, because I like being I'm not a very dedicated workaholic, but I don't think it's a bad idea. But at least for now, because I am not experienced, I'm just I'm just 22. I don't have that much experience, so maybe in the longer run I will feel that it will have a negative impact. But it has certain impacts, like if you're a workaholic, you don't socialize with people, you don't go out enough, so that maybe you just do what you do. It should not be like that. My point here is, you should keep yourself occupied. Okay, forget work, keep yourself occupied. Maybe work, go to parties, chill, play some sport, do everything, lead a balanced life. Just don't keep yourself free, because when you keep yourself free, that's when the bad thoughts hit you, and that's when you feel uncertain about your future.
Right.
Even right now, it's not that I work all the time, so I don't have any uncertainties. Definitely not like that. There are days when I feel so low and things are so uncertain, I just feel like I won't do anything that day. I'll just think about them. But that's definitely not the way to go about it. The way to go about it is to keep yourself occupied all the time.
Great.
I think not just with work. Maybe socialize, go out, have a drink, play some sport. Everything is a good option.
Right.
But don't just be there doing nothing. do something.
Right.
I think that's a
Mhm.
right.
So in the university, what else you do apart from studies and all?
Honestly speaking, right now I really don't have a lot of time because the coursework has been so rigorous, and I have shifted from civil to physics, so I also need to
Hmm.
put in that extra mind, that extra bit of effort
Right.
that maybe I would have a luxury of not doing if had I been from a
Hmm.
bachelor's in physics background, but that's not the case, as you know. But yeah, other than studies, I come home, I cook. It's not that I like cooking, but I like food, so I need to cook something that I can eat
Hmm.
and be happy about it, right? Sometimes I go out on the weekends. I usually go out to different places. Paris is a very beautiful city.
Hmm.
Not even just Paris. The suburbs of Paris, maybe just beyond the suburbs also, there are some few places which are very beautiful. Maybe I go out to that place on the weekends, and some days I play. I am an avid football fan, has been for a
Hmm.
quite long time, and been a player as well for
Hmm.
quite a bit of time. So maybe I play too, but not all the time because I simply don't get that much time, to be honest.
Hmm.
So yeah, other than work, maybe going out a bit, socializing with my friends a bit, playing. That's it.
So
And it
Paris is
keeps me
also a
occupied.
land of food. Like France is famous for its food.
Yeah,
Right.
yeah, definitely it is. You need to have bucks to afford that, and my scholarship does not allow that. So maybe someday, not today, but someday, definitely.
Good. And so you said you are a football fan. So was that one of the reason coming to Europe?
That was not one of the reasons, but it's a plus. I would definitely say it's a plus. So every year there's a ceremony called the Ballon d'Or to determine who's the best footballer, who's been the best footballer that year. And as a perk of me living here, I went to the ceremony this time. Was able to witness it. And it was great. So yeah, it is definitely one of the perks of living here, but not the only. Definitely.
Cool, great. And so coming to Indian academic structure, what do you think are the things that can be improved? Like those are in the near future can be worked upon, and what you would like to as a professor if you get a chance to work on these certain things.
I think the main take back was the exams. I would definitely like to set up better exams. Exams that can be conducted. Sorry, not can be that not be conducted. What should I say? Exams prepared in such a manner that really tests the abilities of abilities of the students. Right. That is one point. Then just test their memorizing capabilities, or then just being repetitive. I would love my exams to be different, and exams that would stimulate thinking and that would help grow the students more in the maybe make them more interested in the field of research. That is definitely one of the things I would like to do. The second thing would be maybe, yeah, as I said, having discussions with the students as if they were my equals, which I think is a bit lacking. There are many research institutes which do that,
Right,
not all
right.
of them are same. There are definitely many people, professors at the personal level who interact with the students in the way they do out here. And definitely I would love to incorporate that. And yeah, the third thing I would like to improve is the pedagogy of teaching. In France, the teaching is very much pedagogical, and that is very good. I think we should also incorporate that in India.
Cool.
These are the main three things. Other than that, I think our system is fine, and yeah, it is fine. Maybe at times it's a bit more rigid, but that rigidity is also sometimes necessary, not all the time. Other than that, the system is not that bad, and in many aspects they are similar. Okay, yeah. One thing I even don't like over here is maybe they put too much emphasis on grades, like even more emphasis than in India.
Right.
But I think we should use that even here, even in India, we should see the student as a whole. All give credit to research and other things he has been involved in, not just the grades.
So in Paris, is it that the credits are also given for like extracurricular activities? Like for example, in new education policy, India has these elements that if even extracurricular activities apart from academic studies would also be awarded credits. So is it something like that or not?
Definitely not something like that. There are different courses. For example, here you can take a course on drama, you can take a course on music, but they are different courses. You can't mix physics. You can't take a course on physics and have a bachelor's in physics, suppose, and take a music course. It's not. I think system in India is actually more flexible than France.
Achha, okay.
No, it's not that. It's not that. Things are quite different, but I would say that in terms of flexibility, the European system and the Indian system are quite similar, I would say.
Okay.
They are quite similar.
Cool. And so coming to your research projects, what all projects have you done during your bachelor's, or if you're involved in any of your during your master's?
So in my bachelor's, the first thing I did was something related to quantum uncertainty principle and the coherent states. So how I showed that the uncertainty principle can be thought of as the direct result from the electromagnetic field theory. And I did some mathematical stuff with it. The second was, this was a personal project. This I did at a personal level. And then the second project was on Dirac equation in curved space-time. And then I showed some features of it. And then I related it with a quantum optics model that is used very much nowadays. It's called the quantum Ray model. The third project, which is actually published currently in Nuclear Physics B, was based on non-commutative field theories. So non-commutativity suggests that so right now, even in quantum mechanics, we have that the space coordinate and the space coordinates, that is x and y and z, they all commute, right? But in the non-commutative field theory, x and y don't commute.
Right.
So there is an uncertainty related with measuring x and y simultaneously, right? And that is what non-commutative theory is. So, and we also know in physics there are things known as symmetries, and the symmetries give rise to conserved quantities. We show that in this non-commutative framework, where x and y don't commute, there can be some anomalies in which conserved quantities may not be conserved. Due to this non-commutative nature. And pretty technical, to be honest. It's pretty mathematical as well. And non-commutativity is actually one of the predictions, not one of the predictions, one of the necessary arguments for the quantization of strings.
Right.
So that's where non-commutativity comes from. That why all of a sudden do you need to have non-commutative coordinates just for the fun of it? You just don't do it for the fun. It must have a physical impact. That's the physical need of the mathematical need of having a non-commutative space-time. Like that, and these are my three main projects. And other than that, I've been involved in other projects as well. So, in the first year in my college, I took a project in fabrication of quantum dots.
Okay.
That was very much experimental, contrary to my, not contrary, which is starkly different from what I have been last years. So, in the first year, I did some of that. Some of fabrication of the quantum dots, and what it is. Yeah, and I will be doing an internship on topological field theories and string theory and string theory this summer, which is going to start from 1st May. So I'm pretty much excited for that as well. It's a 3-month internship.
Great.
That's where my research will be going next. Right now, so in France, the system is you have 9 months of coursework and 3 months of internship.
Okay.
Where 9 months of coursework is pure coursework, 3 months of research, internship is pure research.
Okay.
So maybe in that time I will be able to come up with something.
Okay.
Time to keep some additional research on the coursework I will teach.
So your exams are going on right now?
Not right now. So I had a midterm on 25th.
Okay.
That is yesterday. And I will be having my end term on starting from the week at 11th.
Okay.
Week starting on 11th. And this will be, and within a week we'll be done with that. So
okay.
The course is almost over.
So you mentioned about fabrication of quantum dots. Can you describe your process, what exactly they are, and how the facilities?
The facilities, so I actually forgot because I read through a journal, and the journal had the steps on how to fabricate them, and then we fabricated it.
Okay.
So basically, I really don't remember because it had been such a long time. It had been 6 years, no, 5 years since I last did that project. So,
Okay.
but it's very much and it's also like, had it been in line with what I'm currently doing, maybe I had to remember it. But it is very much different from what I'm doing currently, right?
Right.
I really don't remember or recall how I did it. But the facilities were good. We were able to do that.
So what all groups are there in your university in France? Like theoretical physics groups.
So I think we have, okay, for theoretical physics in France, there is mainly LPTHE at Sorbonne. So these are all abbreviated form of French names,
okay.
which I don't intend to pronounce, and I would definitely get them wrong if I did. So there's LPTHE, and working on theoretical physics. There is LPENS. This group is of the ENS, École Normale Supérieure. So this is a very prestigious institution here in Paris. And there is APC. This mainly works with astrophysics, cosmology, and string theory. There is a group called LPNHE in Sorbonne. It works with mainly the, what do you call it? Phenomenological aspects, and cosmological aspects. This is about Paris, and there are groups elsewhere. Marseille has a very good group on theoretical physics. Oh yeah, there's also one in the outskirts called Orsay, basically called in Paris itself, Orsay. So Orsay has a theoretical physics lab as well. It's called the LPT and LPTMS. And LPTMS, they work with. I'm really forgetting. They work with different things. I think maybe dynamical systems. Yeah, they work with dynamical systems. Right? And there is LPTMC, which works with theoretical condensed matter. And LPTHE and LPNS, as I mentioned earlier, they work with all the theoretical aspects. And then there are certain groups which works on theoretical condensed matter. There's CPHT. This also works on all kinds of theoretical aspects. It's by the École Polytechnique. So there are quite a large number of groups here in Paris.
Great.
And even outside Paris. In Lyon and Marseille and in Dijon, there are some theoretical physics or the mathematical physics groups.
Okay, and how's the experimental, like the proportion of experimentalists and theorists?
So basically, I think it's quite given that there will be more number of experimentalists and there will be more number of theorists. Maybe 1:3. Maybe I'm getting the proportion, but I don't have the exact statistic. It's usually 1:3.
Okay.
Because in experiments, you need a lot of people to carry out the experiments, to do all sort of stuff and to recheck. In theory, you need is pen, paper, and your head, right? It's not a lot of people. You may need a lot of people to. Not a lot of people. You may need some people to cross-check your work or someone to work. Maybe you have some kind of idea that may relate to some aspect, and you're not a specialist in that field. So you may need someone to collaborate with you who is a specialist in that field, and they might help you. But in theoretical physics, especially the number of people collaborating are also very, very less compared to the experimental physics.
Okay.
So I think there are much more number of experimentalists in France and elsewhere in the world than there are theoretical physics.
Got it. So last few questions. So what are some favorite quotes that you have read and that inspire you or that you love? Like, okay, this is something awesome.
Oh yeah, there are a lot of them actually. I think there was one by Feynman. Yeah, fall in love with some activity and do it. Nobody ever figures out what life is all about, and it doesn't matter. This is my favorite, all-time favorite quote by anyone, I guess.
Great, nice. That's nice. And so, last question I had for you is, what is that one life lesson that you would like to share with the audience?
Never stop working hard, because no matter what you do, no matter where you are, this is something that is always going to help you, is always going to elevate you. And I think that's the best thing one can ever say to anyone. That's always keep working hard.
Great.
Because it's very, very important to succeed anywhere in your life, in any area, in any field, and also be a bit smart about it. Work hard and be smart. Be a bit smart about it. But important thing is keep working hard.
Right. Consistency can beat talent.
Yeah. Yeah, there's another quote. I don't know who said it, but it says, "Hard work beats talent when talent does not work hard."
Right. Right.
I think it's from a footballer. It's some related to some footballing aspects.
Okay.
Maybe some footballing manager, or some. It's quoted this about a player, and that is, hard work beats talent when talent doesn't work hard.
Right. Right. Great. So that's a perfect end for the podcast episode. And thank you for joining. It's been a lovely conversation with you.
Same here. It's been a lovely conversation with you. It was a pleasure to meet you. And I've been seeing what you have been doing in the past. It's been really inspiring.
Thank you.
So best of luck.
Thank you
for your future, and where academic pods will, and hope the academic pod goes into a very big thing that we can all talk about.
Thank you so much.
Hope you loved the episode. Subscribe to our show and see you next Saturday.